Welcome back to Database History. When you think database, you probably picture these giant servers humming away in a data center, right? But what happens when you need that kind of power inside a jet engine, a network router, or a medical device? Today, we're talking about Raima RDM, the pioneering embedded database that put the power of relational data right where the action was.
To really get what made Raima so revolutionary back in the 1980s, you have to see the two different worlds of data. On one side, you had the big guys, Oracle, DB2. Powerful, sure, but they were chained to the data center. And then there was Raima RDM. It had a totally different playbook. It wasn't a separate server, it was a library, designed to live inside the application itself.
So here's our game plan. We're going to trace the entire story of RDM. We'll start with its origins as a database built for devices, then see how it packed all that relational muscle into a tiny package. We'll explore the super critical systems that relied on it, peek under the hood at the engineering that made it so fast, and then connect its legacy directly to today's world of edge computing.
Okay, first up, let's go right back to the beginning. RDM wasn't just another database on the market. It was basically inventing a whole new category, a database built specifically for devices. Raima Database Manager, or RDM as everyone called it, was born in an era when every single kilobyte of memory mattered. I mean, every single one. It was engineered from the ground up as a high-performance library that developers could just link directly into their applications. See, this wasn't some separate server you had to connect to. It literally became an integral part of your program.
Now, being part of the program meant it had to be small. But that brings up the big question. How did it manage to be so small while still being powerful? And that right there is the secret sauce of the RDM advantage. Before we go any deeper, let's just make sure we're on the same page. What is an embedded database anyway? Well, it's a DBMS designed to be a component, to work silently inside a bigger system. Think of the software in your car, a patient monitor in the hospital, or a network router. These systems need to manage data, but they absolutely can't afford the luxury of a dedicated database server. That's the exact world RDM was built for. And here's the crazy part. RDM didn't sacrifice power just because it was small. No way. It provided full-blown relational modeling, letting developers define tables, create relationships with keys, and build indexes for super fast lookups. It offered direct access through C and C++ APIs for maximum speed, and yeah, later versions even added a SQL interface for more standard querying. So this unique combination of power and a tiny footprint opened up a whole world of possibilities, letting RDM run in some truly mission-critical places. Let's look at exactly where this technology thrived. In aerospace, where failure is just not an option, RDM was a perfect fit. It found a home in onboard flight systems and in satellites, managing telemetry and operational data in environments with zero room for error and absolutely no way to connect back to a central server. The backbone of the early internet also ran on this technology. Telecom giants embedded RDM right inside their routers and network switches. In there, it managed routing tables and configuration data where every microsecond of lookup speed directly impacted network performance. Over in the medical field, RDM was the silent partner inside patient monitoring devices and laboratory equipment. It was trusted to reliably store and retrieve life-critical data, like heart rate or blood oxygen levels, moment by moment, right at the point of care. And on the factory floor, RDM was often the brain inside industrial controllers and robotics. It managed real-time process data for automation, making sure that assembly lines could run with precision, speed, and incredible efficiency. Across all these different fields, the value proposition was crystal clear. Developers got the power to organize complex data with a structured relational model, but without the massive overhead of a server. As one developer put it, it was relational logic without the overhead. So how did it actually pull this off? That brings us to Section 4. Small, fast, and powerful. Let's take a look under the hood. The process was incredibly direct. An application made a simple function call to the RDM library. That call initiated an ACID-compliant transaction, which is just a fancy way of saying it guaranteed the data would never get corrupted. It could handle multiple users gracefully, and it stored everything in these optimized, super compact binary files. No network protocols, no separate processes, just pure, fast data management. And this really drives the point home. While a server database of the era might consume megabytes of memory just to idle, RDM's footprint was measured in kilobytes. This was the key that unlocked its use in all those resource-constrained devices we just talked about.
This is the feeling you hear over and over from developers who used it back in the day. It was a tool that punched far above its weight, delivering performance and capabilities that just seemed impossible for its size. This brings us to our final section, from embedded to edge native. Let's look at Raima RDM's lasting legacy and how it connects to the technology of today. If you draw a line from the past to the present, you can see a direct evolution. Raima RDM was the embedded pioneer of the 1980s, proving that complex data could be managed locally on devices. Well, the modern edge databases that power IoT and edge computing today are the direct descendants of this very idea. And that's why this final quote is so fitting. RDM isn't just a piece of legacy software. The philosophy behind it, local data processing, small footprint, high performance, is what we now call edge native. It was solving the problems of the edge decades before we even had a name for it. Ultimately, the journey of data is always moving. It started in centralized data centers, moved to the device with pioneers like Raima, and now it lives at what we call the edge. This leaves us with a fascinating question. If data has come this far, where will it live next? That's it for today's look into the past with database history. Join us next time for another deep dive.